Welcome back. In this module, we're going to talk about module 14, and it's going to be interesting. I think it's a case study involving a large winery. And we're going to get started here. And boom. That should start up. All right. Risk management tools for safety professionals. This large winery operation case study was authored by Bruce K. Lyon and Georgie Popoff. I don't know if they did a study or not, but they authored this one. Anyhow, winery case study. It's a large winery, as we said. Their concerns were chemical exposures in bottling, close calls, complaints, and uncertain of risks. They conducted a risk assessment. They identified FSI level exposures and existing controls, FSI being fatality, serious injury levels. They're the highest, I would think, obviously, fatality of exposure. I don't see that term. I haven't seen anywhere else, but in this context. Analyzed risk levels, discussed additional controls, proposed higher level controls, and reassessed the risk. Now, when we first started, the first thing they did was establish the context of a risk management assessment or risk assessment. And in that, the stakeholders determined what they were going to use, what tools they were going to use. And one of the tools, of course, is the risk matrix. And they chose a 4x4 matrix, which is fine. They're not that different. And in all of them, two things that are constants is you get the most serious ones, which are always in red, of course, and those must be handled right away. Obviously, there's some serious dangers, serious hazards there. And then the least serious, which are always in green, yeah, you probably don't have to do anything with them. You probably can't get them any safer than they are. And the middle ones, whatever you want to call them, high, moderate, whatever, they're the ones you're going to have to make some decisions on. You're probably still going to go with the higher one before the moderate one, but then you can make decisions on some of them, and maybe on the moderate ones, put them off for a bit. But it doesn't matter that what these risk matrices said, they're not that different. The theory is all the same. The action level, okay, unacceptable, immediate action required. Operations not permissible except in rare and extraordinary circumstances. For high, remedial actions to be given high priority. Moderate, remedial actions taken appropriate time. And low, remedial actions discretionary. But they put a caveat in here. Procedures are to be in place to ensure risk levels maintained. And that makes a little bit of sense. But now they come up with this hazard inventory. And they're calling these all FSI level exposures, all fatality, serious injury level exposures. And they use past incidents, chemicals and materials, review of process steps, procedures, instructions, job safety analyses, site observations, audits, and brainstorming. Brainstorming is kind of fun sometimes. Together with a bunch of people and just throw out ideas. And that's what they come up with for the hazard inventory, I guess, for all this all of this. I've never seen this done before. But they have different probably departments or processes: harvest, destem, crush, press, fermentation, clarification, adjustment, aging, bottling, warehouse, distribution, and they have hazards listed for each one of those. Now, I can see that struck by forklifts is in 1, 2, 3, 4, 5 of these, and slips and falls are in 2 of them, but slips and falls are pretty much all over the place. Heat stress in harvest, that makes sense. They're outside harvesting stuff, so heat stress there. And so that was an interesting thing, but I have never seen it done anywhere else, hazard inventory. Now, they identified associated controls, existing controls. Well, I don't want to call them associated controls. You know, this is their hierarchy of controls they're using. And again, hierarchy controls they're all the same in theory. So these aren't too different from the one we're using. They added risk avoidance, prevent entry of hazards into a workplace by selecting and incorporating appropriate technology and work methods criteria during the design process. To me, that's the same as you eliminate it. I mean, so substitution, engineering controls, a couple of them throw in a warning as between engineering and administrative, but in my opinion, a warning is an administrative control, and then PPE. So they have existing controls of warning alarms, SOPs for handling, training in chemical use, and PPE. They have 2 concerns. Concern number 1 was pure liquid sulfur dioxide. It's used for dosing tanks inside the buildings, and they do a lot of filling and dispensing. The risks are potential for release during filling and dispensing. Lethal dose is 100 parts per million, and that's pretty low. Cal OSHA, so this must be winery, must be in California, which makes sense too. The PEL, permissible exposure limit, is 2 parts per million. That's pretty small. It can cause blindness, environmental concerns, and they're transporting, dispensing, handling, and storage concerns. Excuse me. Sulfur dioxide gas is heavier than air and can accumulate in closed areas. Whenever you're dealing with any kind of hazardous gas, one of the properties that you need to know is it heavier than air or lighter than air. That'll give you an idea of what's going to happen to it if it is dispersed. Heavier than air, of course, is going to stay on the ground and probably be harder to get rid of. Higher than air is going to waft up towards the ceiling and may be easy to get rid of by fans and stuff. The configuration and lack of ventilation in the bottling area presented a significant risk to employees should a SO2 release occur in the area. So they recognized that there were some problems with the configuration there. They did a preliminary hazard analysis, and this is what they come up with. The task, SO2 dosing using 100% liquid of SO2, hazard health risk from leak or release, 2 parts per million permissible exposure limit, 100 ppm lethal dose. It's heavier than air, and it's EPA regulated product. It's probably EPA regulated because they reached some certain threshold to report it. The current severity is 4, likelihood is 3, so the risk level is 12, and that's in red, so that's obviously a high risk level, and that's what they're highlighting there with it. So the proposed control is substitute with a less hazardous product. Great. They're going to substitute it with a 6% liquid SO2 and K2S2O5, which is potassium, I can read the small print, made of bisulfate effervescent tablets, granular and powder. So they're going to be able to use a tablet in here instead of a liquid. And that's always better when you're handling chemicals, I would think. So they come up with a future severity of 2, a future likelihood of 2, and a future risk level of 4, which it puts it in yellow, puts so in the way less serious the risk category. And they come up here with also, they are, oops, too far, 67% risk reduction, which they're claiming here. And 67% risk reduction is pretty good. Go from a 12 to a 4. The concern number 2, DMDC dosing, dimethyl dicarbonate used to prevent spoilage. DMDC inhibits yeast with a half-life of 3 hours, which converts to CO2 and methanol. Highly specialized metering equipment and training operators. That looks like a pretty sophisticated piece of equipment there, which probably does need some training on. It's located in the metering equipment is located in the same area, the bottling area, so they have the same concerns: limited ventilation and limited means of escape. Exposure shielding limit is 0.04 parts per million. It's 0.04 parts per million. I think it's 0.4 because that's what it is on the next slide. Releases have occurred due to operator error and equipment failure. So operator, I'm always suspicious when I see that it's an accident or an air miss or a release, something like that has occurred during operator error. I find that that's usually just the quick and easy answer, but sometimes it does happen. So there's their preliminary hazard analysis for this one, the DMDC metering equipment in the bottling area. It's health risk to bottling employees from a leak or release in the area. Now you can see it says 0.4 parts per million exposure ceiling limit. Current severity 4, 3, and then 12. And the recommended controls are eliminate the exposure, relocate the unit outside the building, and connect it, of course, to the place you're going to use it with a hose, with open ventilation away from the bottling area. Continue to follow safety protocols and PPE for operator. So here they're taking this unit and just taking it outside and put a hose in it to bring it inside. So now you have this, if there is release, it's going to be outside. So the future severity, they knocked it down to a 3, likelihood 1, and now they have a green risk level, future green level of 3. And that is a 75% risk reduction. That's pretty good. And that's the 2 of them on one page. As a result, they eliminated 2 FSI risks. And I don't know, so what they're called there again, FSI, fatality, serious injury risks, 2 high risks. I guess anything in a 12 would be that. Anything in a red area on anybody's risk matrix would be considered FSI. Makes sense. Case study results, they removed 2 fatal or serious incident level risks, 66% risk reduction for SO2 exposure to employees and community, 75% risk reduction for DMC exposure risk, Improved employee morale. And don't downplay that one. That's pretty important. When your employees see you doing something and then you do something that's for their safety, that will definitely boost morale. Eliminated EPA reporting requirements for SO2 now that they don't have that in those big quantities anymore, or they have it in tablets. They don't need to report the EPA, and that's always good. Low cost for both of them. So both of these controls they put in were pretty low cost, and that's always good too. And they threw this in at the end, sequence of methods used in a risk assessment. Not sure why. Again, anybody has different methods and different ways of doing this. And here they're throwing some things in there like bow tie analysis, which they didn't even use in this one. So I don't know why they put this stuff in here that they really didn't follow these steps, but they put it in here, I guess, just for completeness. And that's all there is to this case study. So that's it for now.